All right, so today we're actually going to talk about three different centers of a triangle. Um, so we got to pay attention to a couple different things here. We got to pay attention to how the different centers are formed so that we're able to identify what kind of center we have when we look at a picture. And then we also have to make sure that we understand kind of the ramifications of that. So once we decide what kind of center it is, then what does that mean for my picture? What parts of the triangle am I then able to find? So we're just going to go through 6.2 kind of covers two of them, and then we'll do some practice, and it's all here on one document. And then we'll move on to the 6.3 notes, which covers one more type. And then your practice will just kind of all be together today. So let's go ahead and get started. So circumcenter, that's our first type. Okay. So circumcenter, you can read, it says, is equidistant from the vertices of a triangle. Okay. So how a circumcenter is created is you are going to take the perpendicular bisectors. Okay, so it's created by three perpendicular bisectors. So you might want to put that up here. So circumcenter is created by three perpendicular bisectors. Okay, so created by three perpendicular bisectors. So let's look at our picture here. So we have a perpendicular bisector there, a perpendicular bisector there, a perpendicular bisector there. So that means these are congruent, these are congruent, and these three are congruent. Or sorry, that last set is congruent. Okay, so there are my three perpendicular bisectors, which then create my circumcenter, P in the middle. Okay, and so that's how it's created. That's how we identify that it is a circumcenter. Once we identify it's a circumcenter, then we know it's equidistant from the vertices. So equidistant. Actually, let me put it up here. Equidistant from the vertices. Okay, so that means this and this and this are all congruent. So once we decide that we have a circumcenter, then we can say that circumcenter is then equidistant from all three vertices. So we're able to kind of discover some information there. Okay, so two big things. You want to know how it's created, and this one is created by three perpendicular bisectors where the three perpendicular bisectors intersect there at P, and then you want to know that it is then equidistant from each vertice. Okay, all right. So that is circumcenter. Okay, so let's look at the second one. The second one is called an incenter. Okay, so an incenter is sort of the opposite if you're thinking about circumcenter. So an incenter, let's start with how it's created. So it's created by three angle bisectors. Okay, so three angle bisectors. So we're going to say there's one angle bisector, there's our second angle bisector, and there is our third angle bisector. So we have three angle bisectors that are going to hit right here in the middle. That's the incenter. Okay, and then what we know from an incenter is it's equidistant T on the end, sorry, equidistant from the sides. Okay, so for circumcenter, we knew it was a circumcenter because of the three perpendicular bisectors, and it was then equidistant from the vertices. Now we're going the opposite direction. Now we're saying this one is created by three angle bisectors, so it's coming out from the vertices, and then we're going to say it's equidistant from the sides. Okay, So you have to be able to identify what the center is and then what that then means about my shape. Okay, so these are the first two that we're practicing with: circumcenter and incenter. Okay, so take this slow. This stuff doesn't come. This stuff doesn't come by just looking at it one time. So you're probably going to have to go back and forth between these notes up here and your practice set. But I want you to first just focus on these first three examples. So these first three examples, 1, 2, and 3, make sure that you're paying attention that it is talking about an incenter. Okay? So make sure you know that it is talking about an incenter. It tells you that in the directions. And then you can go ahead and do 1, 2, and 3 together. Well, I guess if you're there on Black Day, you can go ahead and work together with your groups. You can pause and work together, or if it's e-learning for you, then you can just pause it and work through it yourself. And then you can start the video back up when you're ready. Okay, so the incenter. Remember, the incenter means, let me get back to my pen. The incenter means it's equidistant from the sides. All right, so it's equidistant from the sides. All right, so we're looking at the incenter, right? So there's nothing here to indicate that it is the incenter, but we believe it because the directions tell us, okay? So this is the incenter. It tells us the ND right here is 2x minus 5, and then it tells me NE is negative 2x plus 7. And we know, because N is the incenter in the middle, that those two should be congruent. So let's go ahead and work through that. So we have 2x minus 5 is congruent or equal to negative 2x plus 7. So a little bit of math. I get 4x on the left. I get 12 on the right. I divide and I end up with x is 3. Okay. See, right here it's asking me to find NF. Okay. So that means that NF we know is equidistant with the other two. So all I need to do is just simply plug my x back into one of my other two, find that length, and then I know it should be congruent. So if I plug it into ND, looks like it's 2 times 3, that's 6. 6 minus 5 is 1, so it's going to be 1. So NF equals 1. All right, number 2. Again, we know it's the incenter. It's telling me NG, and it's telling me NH. And again, I know that the incenter is equidistant from the sides. So I'm going to set these again equal to each other. X minus 1 equals 2x minus 6. A little bit of math. We get x on the right. Add the 6 over, and I get 5 over here. So x is 5. It wants me to find NJ, which I know is equidistant and congruent to the other two. So if I plug that in, 5 minus 1 is 4. So it looks like NJ equals 4. Okay. And then last but not least, number 3. Again, we're looking at incenter, so we know all three of these are congruent. It gives me NK, and it gives me NL, so nothing special about this one. We're setting them equal to each other. X plus 10 is going to be equal to negative 2x plus 1. Add the variables to the left, you get 3x. Subtract the 10 over, we get negative 9. We know x is going to be negative 3. Okay? So then I need to figure out NM, which is equidistant to the other two. So if I plug negative 3 in, negative 3 plus 10 is 7. So it looks like NM is going to be 7. All right, so that's working with my incenter. The back is going to challenge us a little bit more. So let's go ahead and flip to that. Okay, so we're going to not mess with 8, 9, and 10 right now. We're just going to focus on these top 4. Okay. So these are a little more challenging because it doesn't tell you if it's the circumcenter or incenter. So you're going to have to use your notes, use what you know about circumcenter and incenter, and decide which is given to you. And then once you decide which is given to you, then you can decide what you know about the triangle, what you know about the triangle, and you can move forward with what's given to you. So go ahead and pause the video, do 4 through 7. And then when you're ready for answers, you can go ahead and unpause. Okay, so let's focus in on number 4. Okay, so first I have to decide what kind of point I have. So it looks like, because I'm given these congruency markers, right? Let me go to my pointer. So I'm given these congruency markers here, here, and here. And I also see the perpendicular markers. It looks like the 3 dotted lines are my perpendicular bisectors. So if I look back up to my notes, I know that my 3 perpendicular bisectors makes this the circumcenter. So P is the circumcenter. Okay? And I know it didn't tell me to actually do that, but I'm just going to do it for my own sanity. Okay, and I know that the circumcenter is equidistant from the center. So I guess I need, what, 4, because we already did 3. Okay, so there I know that the circumcenter is equidistant from the vertices. So PA, right here, I know PA is going to be equidistant to the one that's labeled for me PB. So I know PA is going to be 13. All right, let's look at 5. Okay, so 5. So I need to decide what I have. So I do see these perpendicular markers, but I don't see anything about them being bisectors, right? So I don't know that I have perpendicular bisectors, but I do see 3 sets of angle bisectors, right? Because those show me that those angles are congruent. So looks like my dotted lines here are angle bisectors, and 3 angle bisectors create an incenter. So P here is an incenter. And I know that incenters are equidistant from the sides. So it looks like these 3 segments from the incenter to the side should be congruent. It's asking me to find PS, which I know PS right here is equidistant or congruent to PU, which is labeled for me, so I know PS must be 8. All right. So there was one pretty basic example of circumcenter and incenter. 6 looks a little more challenging. And it is a little more challenging because we see a triangle and then we see some lines going out from it. So we kind of have to decipher what's going on here. Because it is possible for the circumcenter and incenter things. Well, is it I know it's possible for a circumcenter. I'm not quite sure about an incenter. But it is possible for the center things to be actually outside of the triangle. I know that seems counterintuitive, but it really is possible, and that's what we're looking at here. Okay, so if I look here, it looks like congruency markers perpendicular. So we know this is a perpendicular bisector. Congruency markers perpendicular, so that's a perpendicular bisector. Congruency markers and perpendicular. So these are my 3, these dotted lines here are my 3 perpendicular bisectors. I know that these 3 perpendicular bisectors meeting together means that that is a circumcenter. Okay, so we're going to say G is a circumcenter. Okay, so that's my circumcenter. And I know that circumcenters are equidistant from the vertices. So there's actually one that's not shown here, right? This one, and there's one that's not shown that would go all the way down to F that would also be equidistant. It's asking me for GE, which I know is equidistant or congruent to GD, which is 10. So I know GE must also be 10. Okay, so that one was a little more tough, a little more challenging because the circumcenter, was outside of the triangle, but that is possible, so you got to be on the lookout for that. And then here in number 7, again, we see angle bisector, angle bisector, angle bisector meeting here, so we know N is an incenter. And we know that incenters are equidistant from the sides. It's asking me for NF, which I know is congruent to NE, which is labeled, so NF must be 2. Okay, so pretty basic stuff here. The hard part what it seems like. The hard part when we mix all of these different centers together is just deciding what you're looking at. Once you figure out what you're looking at, the math is pretty easy. Okay, let's go to page 3 and learn about one more center. All right, we're not going to look at orthocenter, so you don't have to worry about that. We are going to look at centroid, though. Okay, and centroid is kind of off on its own set of notes because it is a little bit different than the others. Okay, so again, we have to decide, number one, how is it determined? Okay, and then we have to decide what that means. Okay, so a centroid of a triangle. Okay, it says it's 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so a centroid, we know it's a centroid because we see it's a bisector, but then the bisector, it's not a perpendicular bisector, right? Because it doesn't go perpendicular, and it always has to go to the opposite vertice. Okay, so bisector to the opposite vertice. Bisector to the opposite vertice. When those three combine together, that's how we know it's the centroid. Okay, and it's less about congruence here and more about proportion. Okay, so the long side of a centroid is always the side coming from the vertex. Okay, so this would be the long side, which is the 2/3 side. This is the short side, so this is the 1/3 side. So this portion right here would be 1/3 of this entire piece. This portion right here would be 2/3 of the entire piece, and it's always that way anytime you have a centroid. Okay, so this piece up here would be the long side, that'd be 2/3. This is the short side, 1/3. This piece is the long side, 2/3, or long segment. This is the short segment, 1/3. Okay, and we're always going to set up proportion, set up like a little equation here. When we're trying to solve these problems. So let's go down here. I'm going to do number 1 with you, and then I'm going to let you do 2 and 3. So let's look at number 1. So we know it's told to us that P is the centroid. Okay, so it's told to us in the directions that P is the centroid, and it wants me to find Pn and Qp. Okay, so I have to decide what is given to me. So Qn, it looks like Qn stretches all the way across the triangle. So Qn is the whole. Okay, so this is the whole. Okay, so now let's set up what we want. So the whole of 33 should be equal to, or sorry, let me back up. So first thing I want is Pn, right? So Pn is the long side. So the long side, Pn, should be equal to 2/3 of the whole. And the whole we know is 33. Okay, so the long side is always 2/3 of the whole. The short side is always 1/3 of the whole. So we were told the whole is 33. We know Pn is the long side, so Pn is equal to 2/3 of the whole. So 2/3 of 33 is just going to be 22. So Pn equals 22. Okay, then we also need to find Qp. That's the other thing it asked me to find. So Qp is the short side. Let me do another color. So Qp is the short side here. So Qp, that's a bad Q. That's better. Okay, Qp, the short side, should always equal 1/3 of the whole. So 1/3 of 33 is going to be 11. So Qp is going to be equal to 11. Okay, so short side is equal to 1/3 of the whole. Long side is equal to 2/3 of the whole. Go ahead and pause the video, do 2 and 3, and then you can start it back up when you are ready to rock and roll. All right, number 2, Qn, again, is the whole. So Pn is the long side. So Pn should be equal to 2/3 of the whole of 45. So that means Pn is going to be 30. Okay. And then Qn is the short side. It should be 1/3 of the whole. So Qn is going to be 15. Okay. Pretty straightforward stuff. Okay, and then again, Qn is the whole. So I want Pn. So PN is the long side, so it should be 2/3 of the whole. So PN looks like it's going to be 26. Okay. And then QP. Oh, you know what? I messed up on number 2. Whoop. Let me back up. Sorry. I don't want to mix you up. This part up here, let me get my eraser. This part up here should be actually QP, right? Not QN. QN was the whole. Hopefully you caught that when I was going through there and you were like, what the heck is going on? So let's fix that. Sorry about that. Too many letters bouncing around in my brain. So that's QP. So QP is the long side. Or sorry. Oh, I'm all kinds of messed up. Sorry. QP is the short side. So QP is 1/3 of the whole. So QP was 15 back there. All right. Now let me finish 3. Sorry about that. So QP, get the right letters this time. QP is the short side. So it should be 1/3 of the whole, which is 39. So QP is going to be 13. All right, let's flip to the back. Okay. So actually, I'm just going to have you guys do 4 and 5. We're actually going to skip this stuff down here. Let's go ahead and do 4 and 5. So go ahead and pause the video, do 4 and 5, and then you can unpause when you're ready to, for the answers. Okay, so on 4 and 5, it tells me point D is a centroid. Okay, it wants me to find CD and CE. Okay, so the difference between 4 and 5 here and the first 3 that we did on the front was the first 3 that we did on the front, they gave us the whole, right? On this particular problem, it does not give us the whole. So we got to pay attention to what is given to us and how it fits in, okay? So remember, the whole is equal to 1/3 of the short side or 2/3 of the long side. No, I said that backward. Sorry. The short side is equal to 1/3 of the whole. The long side is equal to 2/3 of the whole. Okay, so now let's go ahead and see what that means. So DE is the short side, so it gave us the short side, right? So the short side, 7, we know, should be equal to 1/3 of the whole, and we don't know what the whole is. That's one of the things we're trying to find, right? We're trying to find CE, so let's go ahead and find that first. So 1/3 of CE, okay? So opposite operation, to get rid of my 1/3, I would just multiply by 3 on both sides, so I end up figuring out that I know CE should be 21, okay? So CE is 21, and now what's the other piece I need to find? CD, so CD is the long side, so I know the long side CD should be equal to 2/3 of the whole, which now I know is 21. So 2/3 of 21 is just going to be 14. So I know CD is equal to 14. Okay? So it's kind of like a puzzle. You got to figure out what you know, how that fits into the equation that you're working with, and then work your way through that way. Okay? All right, let's look at number 5. So number 5, it tells us DE, so it tells us the short side. So my short side, which I know is 12, is going to be equal to 1/3 of the whole, which the whole is CE again. Okay, so multiply by 3 on both sides. I figure out that CE, the whole, is equal to 36. That's one piece of information I need. And then I also need CD, which is the long side. So CD, the long side, should be 2/3 of my whole, which is 36. So 2/3 of 36 is going to leave me with what, 24? CD is 24. Okay. So you got to be careful on those kind of problems. You got to pay attention to what is given to you, and then what you're trying to find. And it's all kind of just a puzzle. Okay. Short side is 1/3 of the whole. Long side is 2/3 of the whole. So you just got to kind of plug in what you know, and move forward from there. So those are the notes for 6.2 and 6.3. You can go ahead and move to working on your preparation.